Good morning, everyone. Welcome to Serverquarium 2013. We're going to take about an hour or so and take you behind the scenes of the Serverquarium and kind of give you a glimpse of what we did to make it go and what it's built on, how it works. And my name is Steve Cole. I'm the Director of Technology Services for Extreme Consulting. And we're the team that's had the pleasure of running the Serverquarium for the last 4 years here at MMS. And together with Paul Gavin from HP, who've been providing the hardware solution, including this year's cloud solution for Microsoft configuration. We're going to be the session host for today. And everyone does know what the Serverquarium is. I'm not talking about anything. That you're in the right place, and you know what I'm talking about, right? Everybody's been by and seen the big thing wrapped in plexiglass with blinky lights. Okay, let me pretend you don't know. So what it is it's a private cloud-based system that we're using to host all of the hands-on labs here at MMS, as well as the instructor-led labs. It's 2 racks of HPC class blades together with a storage array from 3PAR, running the full Microsoft stack together with some I/O accelerator cards from our friends at Fusion I/O, and management packs and integration packs from HP and Fusion, some custom stuff that we've done at Extreme, all put together to create this very real-world private cloud solution. And we'll get more into that as we go along. So just to give you a quick overview of what we're going to talk about today, we're going to bring some friends up to kind of kick it off. We're going to bring up Jeff Woolsey from Microsoft and Jeff Carlett from HP. Then I'm going to talk about why we felt the need to put together a private cloud solution to run a bunch of labs at an event like this. And then Paul's going to talk about kind of what's under the hood, go into more depth on the actual solution. And then we're going to bring up the guys who actually built it, made it all happen, and give you some time to kind of go do a Q&A with them, ask them some questions about what makes it work, challenges they faced. So let's go ahead and bring up Jeff Woolsey. Most of you probably know Jeff. He's the Principal Group Program Manager for Hyper-V within the Windows Server team. And Jeff Carlett is the Director of Product Marketing from ISS, the team that brings you the ProLiant and the cloud services or the cloud solution for Microsoft that we're using for the Serverquarium. So come on up, guys.
Excellent. Excellent.
Thank you.
Actually, coming up here, I'm Jeff Carlett, so I'm from HP, one of the directors in our industry standard server group. I've got our infrastructure management portfolio and also our key partner portfolio as we integrate into core partners such as Microsoft. And if we advance to slide 1, just a couple names, a couple words. You know, this Serverquarium and what it is delivering to customers of all sizes it really represents a lot of core values and virtues. And I captured actually a couple words just from the tours that were coming through about what our collective offering can provide. And this, to me, from an HP perspective, is truly our converged infrastructure strategy and seamlessly linking it into Microsoft's cloud strategies. We've got a joint vision for cloud that is unified.
Yeah.
It's built on traditional infrastructure, private cloud environment, being able to move into a hybrid cloud using public services such as Azure.
Well, and take a look here for just a moment. So before we even get into the specifics, you're looking at everything that is powering over 650 lab stations in the hands-on labs. And let me be very clear and provide some context here because it's very easy to look at that and not realize just how far we've come. Just a few years ago, to do 650 plus labs, it wasn't 4 racks. It was 32 racks of servers. That was merely back in 2008, 2009. So the hands-on labs, for you guys who haven't had a chance to play with those yet, it's one of the most popular things we do at MMS. And I've talked to folks that come to MMS, don't even go to the sessions. They go and spend the whole week in the hands-on labs. And they tell me, look, I can get the sessions or I can watch them online later. I can hopefully grab that content. But for me, the huge value is I can play with everything that Microsoft offers in System Center, all the hands-on labs, actually walk through these things at my own pace. There'll be guys waiting at the door when we open the doors to go right into the hands-on labs. And so we've been doing this for many, many years. Well, in the past, this was all done on physical servers. This was 32 racks, over 570 physical servers. Let me say that one more time. 570 physical servers. So from a physical footprint standpoint, it would fill this room. Okay? Think about that for a second. 32 physical racks of servers. That's it now. It's 4 racks. I can put it right over here in the corner of this room. So from a physical footprint standpoint, it got dramatically better. And that eases a lot of things. Number one, just transporting this. Okay? Because the way we set this up, we configure all this Microsoft, we get it all ready up in Redmond. Guess what? We put this on a bunch of 18-wheelers, and we drive them on over here to Las Vegas, to MMS. Okay? It then takes a good day, day and a half to unload 32 racks of servers. That's it now. 4 racks. So from a power standpoint, just from a power standpoint, we're seeing over a 14x power reduction. Who wouldn't want to save 14x on their monthly power bill? From a physical footprint standpoint, again, it sits over here in the corner. I mean, please, if you haven't had a chance to go peek, walk in there, take a look. It's beautiful. It just fits in the corner. It's all there. So you're talking from a physical footprint standpoint, from a power footprint standpoint, it's just amazing how we've been able to compress that. And every year, 2009, 2010, 2011, 2012, we refined it further and further. This isn't something we just came up with one day and said, yeah, that's how you do it. No, every year we've built the learnings that we've learned from MMS and how we deliver this solution. We've gotten better and refined it every year. If you look at the architecture we have here, everything here is redundant. Everything here is optimized and balanced throughout the entire system. And it looks very different than the architecture we had back in 2009. 2009, we didn't have blades in a blade chassis. We had a whole bunch of 2U, 2-socket, traditional-looking servers. Back then, we used iSCSI storage with gigabit NICs. We used gigabit storage. In fact, if you looked in the back of those servers, you saw they had anywhere between 5 and 6 NICs per server. So if you do all the math, we literally had hundreds of Ethernet cables in each one of those racks. Okay? Contrast with what we have today, it's all 10 gig fiber channel. It's all 10 gig Ethernet. It's all fiber channel. There's literally, you can count the cables. There's so few of them. Everything is converged here. And so you look at these tenets here, flexible, federated, autonomic, innovative, etc. Yes, all of this and much more. And this has been just continuous learning that we've delivered since our very first delivers of MMS. One of the things I like to point out is, back in when this was all on physical machines, it meant we deployed and nothing was dynamic. Okay? So it meant if we had 600 labs we were going to deliver in an hour, we had to provision each one of those servers and hope we got it right. So this is a real-world problem, by the way, that absolutely, fundamentally is what cloud is all about. So if I had 570 labs I need to deliver at noon, okay, so maybe 50 of those labs are VMM, maybe 50 of those labs are service manager, maybe 50 of those labs are configuration manager. And so we deploy those on physical servers. Well, what happens when everybody shows up at noon, and in fact, all of them want to do the VMM lab? And so 200 people show up to do the VMM, but we only provision 50. So what did we have to do in the past? We had to say, we'll take the first 50, and the rest of you guys will have to come back to a later session. Oh, what if I'm going to be in sessions the rest of the week, and that was the only time I could slot it in? So it wasn't dynamic, it wasn't fast, it wasn't flexible, management was a pain, because we were doing everything, like I said, with lots of NICs, lots of gigabit, lots of storage here and there. There was no intelligence in the storage. Okay? It was all just very simple block-level storage. Again, that's where we were a few years ago. Now you're looking at a fire-breathing dragon here. You want auto-tiering storage. You want maximized efficiency of your networking, of your storage, of your compute, of your memory. It's all there. And this thing is fully dynamic. Fully dynamic. So we'll get into that more, but just to give you a little bit of context, because a lot of people come up here and look at it and go, wow, that's really cool. And it is really cool. But when you put this in the context of this used to be 32 racks and 570 servers, just the amount of people required to move that amount of hardware, okay, just to transport it. We were able to actually get rid of an 18-wheeler, okay, because 32 racks takes up a lot of space. Well, guess what? When you go down to 4, you need 1 less semi. So that was a nice benefit as well. So there's all sorts of benefits by being able to move to this. And we were doing tours, and we were walking people through the lab yesterday, and I don't know how many people kept telling me I could run my entire business off this. Yes, most of you probably could. So we got a lot of goodness here. We'll talk about more about the Serverquarium.
Yeah, great. And my only comment is this is here today. This is now. This is truly HP and Microsoft coming together as one. So, I mean, let's cut this and let's get under the hood and really see how this thing ticks.
Thank you, gentlemen. So why a private cloud? I mean, you're just doing labs, right? Is this a marketing exercise? Are we kind of going through the motions here because we can, or is there a real reason why we're doing this? And the truth is there is a real reason why we're doing this. It's not a marketing exercise. It's not fluff. As Jeff talked about, we had some real challenges that we were trying to address, and it's been a process of iterating against this solution over time. As he mentioned, we started in 2009. Everything was on physical servers. Power consumption's through the roof. Huge footprints, a mess to manage. And then we get into 2010. We're like, okay, let's virtualize. So now we're virtualized. We're down to 41 servers. We've got a ton of VMs. Our power use is down quite a bit, but it's still difficult to manage. It's not a scenario that we really wanted to present, and it's not optimal for how we want to deliver content. So now, in 2011, it's the first year of the private cloud. And we're down to a similar configuration to what we have today. We've got 32 servers and 2 racks. We've got SAN storage. We're running a ton less memory because we're way more optimized. We don't need that much resources. We're still up to 40,000 virtual machines, but our power footprint is down to 8,400 watts. Everything's centralized. It's much easier to manage. In 12, we cranked it up some more. It's a big launch year for Microsoft. You've got Windows Server 2012. You've got System Center 2012 coming out. So the labs are really complex. More VMs per lab, more RAM per lab. Now we've got the 3-par storage, and our VM count is through the roof. We're over 50,000 through the week. So what can we do with all this power? Well, we can spin up over 500 VMs a minute. Easy. We're pulling, if we need it, over 8 million IOs per second through the 3-par and the HP IO accelerator cards from Fusion IO. CPU utilization, when I originally spec'd this out, I went back and I looked at the data from 2011 and 2012, and I kind of extrapolated out where we were going to be in terms of what our utilization was. And I was off by about 10-15%. We're actually running in the neighborhood of about 20% utilization. We've peaked briefly at 30%, but for most of the time, under what would be considered heavy load, all of the lab stations are full, we're running about 15 to 20% on the CPUs. And all of that is running with the centralized web-based self-service portal. And most of you have had a chance to go out to the labs. You've sat down at the station. You get your portal that comes up, and all of your labs are listed there. You click on whichever one you want. There's a whole series of automation that kicks off behind the scenes on that. And we're provisioning and spinning up those virtual machines just as you click on it, and then presenting that back out to you. So just to give you an idea, I went through and looked at all the labs. This is the most complicated one I could find. So this is deploying and configuring servers with Server Manager. So 8 VMs, 20 gigs required, 32 vProcs, 190 gigs on the SAN, and 2 virtual networks. Now that in and of itself is a pretty decent workload. But then we have to remember that every one of those labs and every one of those user stations has to be completely isolated. It has to be private. It has to be secure. If you're doing this one next to someone who's doing a config manager lab, you can't have overlap. You can't interfere with what that person's doing. It has to be completely isolated. So if you think about it, at any given point, we could be running as many as 650 completely separate and isolated Active Directory environments with multiple enterprise-type workloads, all simultaneously. And then, when you're done, we have to kill that, remove it, purge it, and spin up the next one. So it's a pretty unique workload. And it's a bit more complicated than the average enterprise environment. But to me, that's a proof point. If we can do the crazy stuff that we have to do to support all of this stuff on a cloud system like this, think of what you can do with a more traditional enterprise workload. So just some stats as of this morning. We have launched over 6,500 labs since we started Monday morning. with, I'm sure we're probably around 22,000 virtual machines that have been provisioned and launched since we kicked off Monday. And we've had a peak of about 2,500 simultaneous virtual machines running within the system. Remember, I said we never went above 30% CPU utilization. So 2,500 VMs running these unusual workloads at a low CPU utilization. And then there's the instructor-led labs. And those are happening simultaneously. They're on a schedule. And to do those, we're going to provision an average of 1,400 virtual machines out to 400 stations in 4 different locations here at the event 5 times a day. And we're going to do it in under 10 minutes. And the way that we do that is we use the same tool sets, the same applications, the same technologies that are available to everyone here. Although we work closely with Microsoft and we work closely with HP, we don't have one-off builds. We don't have special thing. We didn't go to the product group and go, hey, give me a special build of such and such that does this. It's all straight out of the box. It's the same stuff that everybody else uses. We're using Active Directory to control availability. We've got dynamic memory that's increasing our efficiency as we're running these virtual machines. And then System Center is monitoring and managing it all together with all of the plugins and the integration and management packs from HP and from Fusion IO. And we're doing it with Orchestrator and we're doing it with PowerShell. I was told that there are well over 3,000 lines of PowerShell code behind the scenes that are running a lot of this stuff, and you guys can to talk to these guys when they come up in a minute. But it's a lot of work to put everything together. We've got Orchestrator that's doing a lot of the runbook automation and provisioning of things, responding to the portal request when you click on a lab. And just as an example, I took this screenshot last night. And this was as the labs were winding down. But at that point, we had 2,000 virtual machines running, and you can see the stats. I will say that it wants to keep going by itself. Because we do shut everything down at night, it's a little misleading when you see the average, the 24-hour rolling average at 9% CPU. We do have quite a period where everything's turned off. So it's more. It's better to look at the peaks, and you can see the peaks just kind of poking up above 20%, and the same with memory and with storage. And then we're monitoring it all with Operations Manager. And I grabbed this screenshot this morning because I thought it was a really good example of what we're able to do with OpsMan together with the HP management packs that we get through Insight Control for System Center. So you can see that with that installed, Ops Manager will actually draw out everything all the way down to the power and thermal. So we can look at individual fans, we can look at individual power supplies, all the way down to the interconnect bays in the back of the chassis. It's a very granular view, and it means that at a glance we can look and see what is the health of our overall system. So we're not wondering, we're not having to pop through a bunch of different consoles to try and figure out what's going on. We've got everything we need just at a quick glance. Now, this is not, as I mentioned, a traditional enterprise workload. It is highly customized to meet the unique business needs that were given to us to run the labs. So we have some things that are part of our priorities that are probably very different from a traditional enterprise environment. We want anonymous logouts, and we need really rapid response times, and we need isolation for each of these environments. The things that we don't need are probably a lot closer to what your actual priority list looks like. We don't necessarily need high availability for the user sessions. If you sit down in the lab and something happens, we lose connectivity or the lab doesn't work properly, we'll just spin it up again. What we do need is high availability on the back end to continue to spin those up and continue to provide them. So HA is still important to us, just in a different way. We don't really need 5 nines of uptime, even though we have it. And user security is a bit defined differently for us. It's more about isolation from a traffic perspective than a security perspective. But like I said, everything that we use and everything that we've done is all from the same toolbox that everyone else has. There's no magic, no smoke and mirrors. And the thing to me is once you build out a cloud environment, you create your own private fabric, at the end of the day, you've created your own custom platform. And it's unique to your environment, it's unique to your needs, and that's what we did. It's very unique to what we do, but it's applicable to what everyone else does. And the goal at the end of the day was to prove and provide a real proof point that private cloud's a real thing, that we can use it to do the same types of things that you would do in your enterprise environment, and let's show it, and let's prove it. And let's put up all the data and all the metrics on big giant screens all the way around so everyone can see that we're really doing it, it's really working, and it's providing a service throughout the day.
Steve, can I add one comment to that?
Absolutely.
So go back to that last slide for just a second. So one of the things, he's right that it's custom, but actually in many ways this is actually far more difficult than you will ever deploy. Let me give you one great example. So we talked about all of those different labs, and he showed you that diagram that had all of those VMs for a lab. So one of the things I really want to reinforce is when you go log into a lab, it's not just firing up a VM. That's simple. We did that years ago. That's old hat. When we fire up a lab, that is what's actually happening on the back end. Think about that for a moment. We're firing up 8 VMs, 20 gigs of memory, 32 virtual procs, using 190 gigs of storage and 2 networks. And we're doing this the moment you sit down and you say, I selected this lab and I click deploy. Okay, think about, wow, I would love to have a service catalog. I would like to have different deployments of SharePoint, Exchange, SQL, Dynamics. Here's a small, here's a medium, here's a large. That's what we're doing in every one of these labs on steroids. Because it's not just a typical out-of-the-box. This thing is fully configured and locked and loaded with, in this case, 8 different VMs. The other thing is we have to be able to deal with any type of scenario from a deployment standpoint. So for example, there could be a case where everybody sits down and goes, you know what, wow, that looks really cool. So every person, all 650 people labs, could fire up this same lab at the same time. Think about what that would look like to your I/O. All the storage guys just went sheet white. Okay? Yeah. Okay, so we have to deal with the fact that, hey, literally everyone could go fire those up at the same time simultaneously. We also have to deal with the exact opposite. What happens when everybody goes in and actually 650 labs fire up 650 completely different unique labs? Oh, that gets even crazier because now nothing or very little is cached. So we have to deal with both ends of the spectrum, which actually makes this far more difficult. How many people, people talk to me about VDI. In case of VDI, it's most likely a common image that a whole bunch of people are dealing with, and they're all logging in at 9 a.m. and you're getting a boot storm. This is like VDI on crazy steroids, because this is literally everybody starting at 9 a.m. and they're all clicking deploy, but they're all firing up 5 to 8 to 10 VMs simultaneously. None of them are cached. None of them are, they're all unique. So this creates an even bigger level of complexity and challenge, and this solution solves it without breaking a sweat. You saw him with the CPU utilization numbers, 20%, the high peak we'd hit 30. We've been running thousands of VMs, and even at the middle of the day under maximum load, this thing isn't even breathing hard. Okay, so that speaks to the overall scale and balance of the solution. And one thing I want to always remind people of is I always get people fixated on the wrong metrics when it comes to cloud. For example, I always get do I buy the 2.6 gigahertz processors or the 3.2 gigahertz processors? And honestly, I haven't been compute bound for a really, really long time. Most of the time, I'm waiting for storage to catch up. And the key to scale and performance is balance. It's balance across the entire system: compute, memory, storage, and networking. And in this one, I mentioned this a number of times as I was looking at the whole system yesterday, which is I'm not even sure where the bottleneck is because it is so perfectly balanced. My guess is that you would continue, if I sat there all day and just fired up more VMs and fired up more VMs, eventually we'd exhaust all the physical memory in the machine. Because I don't think we're going to exhaust CPU or storage at this point. That's my guess. But we support up to 8,000 VMs in a cluster in Server 2012, and there's no doubt in my mind that this system could easily do 8,000 VMs. We're doing 2,000, 2,500 now, and we're not breaking a sweat.
Yep. Thanks, Jeff. So now, Paul's going to talk about the hardware and the underlying platform that drives the solution. So, Paul?
Okay, hi everyone. Hi. Still there? It's tough to follow the energy of these guys, but I'm going to try my very, very best. So I'm excited because it's kind of interesting. We did this and Dung and these guys, they built it, and they're crazy because they took on a challenge that was a very, very, very short time frame. How many of you would say, in 3 or 4 weeks' time, I'm going to build a system that I'm going to give to my end users that's going to support thousands and thousands of virtual machines? Crazy. And it was really visible. Because those of you who went to Brad's keynote, he was scared there was no internet. We didn't need the internet. This is a private cloud that's in your space that we built that you can use. And what I want to talk to you about is, this isn't some science lab that we've got out there. This is something that you can buy today. And you can buy it in various guises and put it together. And you can put it together yourself. Maybe you can call on Dung and call. You can put it together yourself. But you can put it together, and we can help you put it together. So what I wanted to do was to talk about the key components that are in this thing and how we're working with Microsoft. And we call it our virtual system environment or our cloud solution. And so it's based on our virtual system VS3. So I'm not going to go through all the points in this slide. I just want to pick up a couple of things. It is designed specifically with Microsoft in mind. It's Microsoft Private Cloud Fast Track compliant. What does that mean? It means that we've worked with Microsoft. There's no single point of failure. We work it and it scales. And you can buy it from HP either as a sum of the parts, or you can buy it from us as a complete solution with storage, networking, fiber channel over Ethernet, 10 gigabit Ethernet, and build all this stuff together. And I'm going to drill down and tell you what those components are and how you could buy them. So this is our overall thing. So if you're talking to your HP rep and you hear the word cloud solutions or you hear the word virtual system, think of the Serverquarium. Think of those components that were used to build that. And you might buy it as a package, or you might buy it yourself. And you can learn from what we've done here about how to do that. So you've seen a lot of the statistics, but basically this is our Generation 8. It's our latest blade server technology. 32 of them. And we have, for compute, we have these. Then we have our management DL360s. And they're designed in a highly available environment so you can set up System Center. Because the compute is important, but my God, System Center is even more important. In this environment, if System Center, your nodes go down, you're in trouble. So we've designed this as highly available. And then we have our Ethernet switches and our storage and data networking. So those are the fundamentals. And from a Microsoft perspective, it's obviously a Microsoft private cloud with SCVMM and SCOM, and we're using operations orchestration. So again, what I'm going to focus on is how does that hardware integrate with Microsoft System Center? And how are we using those integrations? And how can you use those integrations for both servers, storage, and networking? And I'll give you specific examples of what we're doing here and what you can do. So this is the server management. This is SCOM. And if you go out there, you'll see all of these screenshots. I'm not going to get into this in great detail, but basically, with System Center, we do this. We have like 5 different integration points. Basically, starting on the left-hand side here, we do bare metal OS deployment. So you could actually use SCVMM with HP's ILO and HP drivers to do a bare metal deployment of a Proliant blade server or rack server from SCVMM. You can connect to our ILO management, so you don't have to leave System Center. The whole design goal here is, if you're a System Center administrator and you want to build a private cloud and you want to manage and monitor storage and networking and servers, we provide the integration that builds into System Center, that builds into Microsoft Private Cloud, that allows you to do that. So for a server, we have bare metal deployment, we have driver and firmware updates, you can have detailed HP inventory for asset management, we can build automated virtual machine management, we have a Pro Pack that gets an alert from a performance issue, SCVMM, and allows you to automatically move virtual machines from a machine that is an impending failure. So those are the integration points for server management. So server management is really important. But over the last year or so, we've been steadily increasing that capability, not just for server management, but for storage management. And with Windows Server 2012, we're able to do that, and I'll drill down into that. So here's our storage. 4 key points in our 3-power storage. Our 3-power storage is a tremendously popular range, and it's growing at a pretty fast rate for us. And there's 4 key things. It's autonomic. And what does that mean? It will automatically move data between different tiers of storage for you. So you can have nearline, and high speed, and slower speed, and it will automatically move it. We can actually guarantee that you can reduce storage capacity by using our dedupe technology. It's multi-tenant. Multi-tenant means that we can actually double the VM density, and we can actually handle different types of requests from different types of applications on this one storage unit. And federated, we can actually do non-disruptive data transfer between 3-power and other storage. So again, it's totally integrated, and it's a key linchpin of the environment that we have out there. So for storage management, I don't know how many of you are running different storage vendors, products, EMC, or NetApps, or even HP, and how many different storage management utilities are you using? It can be a nightmare. With System Center 2012, specifically SP1 and Microsoft support of SMIS, we have been able to integrate a lot of the storage management capabilities. Specifically, we're talking 3-power here. It supports SMIS, and we have integrated that support into System Center Virtual Machine Manager. So if you want to build a Microsoft cluster for Microsoft Private Cloud, it will go and automatically determine where the LUNs are in a 3-power, allocate those, determine the class of storage that you want, and allow you to build that Microsoft Private Cloud, all from System Center Virtual Machine Manager. And this is really important, because I know that lots of people have different storage management tools. This will not eliminate every single storage management utility. Don't get me wrong, I'm not saying that. But it will make it a lot easier. Especially, so how many people here are System Center administrators? Most of you. How many are storage administrators? Some. Do you work with the System Center guys to do this? Well, I think at one point you will be. So that's the BMM storage. And so we also have integrations with Operations Manager. Again, the goal here is to allow you from Operations Manager to determine the storage capacity and whether you have any issues with that storage, and work with your storage administrator to make sure that works. So this is a tremendous difference in the paradigm for building private clouds. And we're working really closely with Microsoft to make this super efficient on 3-power. The next thing is our Virtual Connect technology. And it's interesting. I don't know, maybe Don Carson, how many virtual networks that there are in this environment. I know that we built a system that had 8 nodes. And just to build a Microsoft private cluster with your management network and your high availability networks, there were something like 60 networks that you had to build. And if you weren't using Virtual Connect, you would have all these cables coming out of the back, all these servers. Now, Virtual Connect essentially allows you to eliminate, by a factor of 100 the number of network cables or fiber channel cables that you would have, because we're using fiber channel over Ethernet. So this is a tremendously powerful technology. So Virtual Connect is built into our Blade servers. And sometimes if you're not a network guru, it's difficult to understand what this Virtual Connect technology is. How do you map an uplink to a downlink, to a virtual network to a logical network? How can you, as an administrator trying to build virtual networks for a virtual machine, how can you visualize that? How can you understand how to do that? I'm going to show you in a few minutes what we're doing, what we're releasing in a couple of months. We'll show you a technology preview of how we do that and how we visualize this to make it simpler for you as a System Center Virtual Machine Manager to do that. So just another thing about the network. You can imagine the network traffic that we have here between all these virtual machines, all heartbeats. And on the left-hand side is something that we would do with our traditional rack servers or different Blade servers. All the traffic would go up to the top of the network switch and come back down again. So if you're doing a live migration or you're doing anything that involves traffic between the blades, that traffic's going to have to go up to the top. Every hop that packet makes is expensive. Every hop that packet makes is going to slow down what you're trying to do. With our blade servers in Virtual Connect, we have something called IRF, and what that does is it makes sure that all of the traffic that's in that blade server stays in that blade server. So what you do is you eliminate all of this, and we can actually, we've measured performance of like 4 or 5 times faster live migrations because the traffic hasn't had to go up to the top of the network switch and come back down again. So so Virtual Connect gives you a value prop that you've got a whole lot less cables. It's a lot less simpler. And also, it reduces the network traffic going up and down the stack. And again, we're using all of that technology in the Serverquarium because we're using Virtual Connect. We're using Virtual Connect for storage and for cluster interconnects. And maybe these guys can tell you when they come up how many networks there are, but there's going to be several hundred, I would think. So that's the Virtual Connect. So that's physically the benefit and how you'd manage it. The issue has been, how do you visualize that in VMM? When you're building that cluster, if any of you have built a cluster or a private cloud, you know you have to determine what your networks are. They're NIC team, they're highly available, and you have to be able to map the names of those physical NICs to logical NICs and how that's going inside your virtual machine. And that can be difficult to do, and I've seen people with diagrams up on the wall of how this works so they can understand it. And there's some bright people who can do it inside their head. I know that I can't. So that's the issue. So what we're doing with this technology preview, and we've got a demonstration of it running out on the floor with Doug DeWord. But what we're doing is we're taking all of that physical information that's in Virtual Connect, and we have something called Virtual Connect Enterprise Manager. We're taking all of that information and we're mapping it into System Center VMM. Physical to logical, virtual to logical, and we're all taking it in there. So what do you end up getting? Here's what you end up getting, and I think this is a really good diagram. It shows you both the external switch where it's going to, the uplink ports where the flex NICs are in each module. And per virtual machine, you can actually drill down and look at this information and topologically map it all so that when someone says, well, there's a network performance issue, or there's a network failure, this is easy for you to do. And this is, I think, a tremendous value add with the physical and the logical capabilities that we have with Virtual Connect. Last thing I'd like to talk about here is something that we're doing, and I'll try and explain this logic to you. We're actually using HP I/O accelerator cards, and we have these in our blade servers. So what are they doing? Basically, what they're doing is that when we want to create these hundreds of virtual machines in in 8 minutes between classes, we're using this Fusion HP I/O accelerator card to do very, very high-speed data transfers. This is something that I think is unique for this environment because it's highly unusual that you would have to create this number of virtual machines in such a small time frame. But again, this is a standard technology that HP sells as a mezzanine card for blade servers. And the benefit here is that we are able to really quickly create these virtual machines. And then as you're running a virtual machine and you're modifying a lab, there's lots of I/O associated with that as well. And these cards help with handling that excessive I/O. So this is something that's non-standard. But if you look at the analogy, and if you have something that's like that, then you could get a benefit from doing this. Again, standard HP products, these are not included in the core virtual system, but it's a technology that the experts from HP and Extreme have worked together to create something that provides significant value add. And it works, because if you think about it, you walk up to a lab, and as Jeff said, this is a brand new lab, it was going to be 50, now it's 100. You've got to go and now dynamically create these virtual machines for these people in real time. And you couldn't do that. So in summary, we've got high-performing servers, and we've not been CPU-bound. So we know that with 32 blade servers, we can handle this number of virtual machines, and you could do that. We've got really, really high-profile networking environments with lots of networks that have to be configured quickly and simply, without lots and lots and lots of cabling. So with our virtual connect technology, we've been able to do that with a minimum number of cables. And then you want to manage that environment from a system center, So we've integrated that networking capability into System Center to make it easy to manage for you. And you want the storage subsystem that's going to handle all this. And again, we work with Microsoft to build integration points into System Center. So it really is very, very, very complementary. Microsoft and HP are working closely together. We win because we want you to buy our blade servers and our networking and our storage. And Microsoft wins because Microsoft wants to have a differentiator with System Center 2012 to build private clouds easily and manage them easily. So we think we've kind of got a perfect combination that we're committed to with Microsoft moving forward, that you can start by buying today and then build and modify for the future. So with that, I don't know why. You guys must be really interested here. I'm taking orders at the door. No question, sorry. No. You have a question before we go to Q&A? Yeah.
We're talking about converged network adapters, yeah? Do you utilize data center bridging features in our labs from the infrastructure point?
So that answer is so simple, I'm going to hand it to Dung and
We kind of introduce some of the guys. This is Dung
Next
Huang.
slide.
Conrad, come on up.
That should be one
First,
slide.
give these guys a round of applause, please. Okay. It has been an absolute pleasure working with these guys for years. These are two of the brains behind making sure that we deliver such an awesome solution. So these are guys that are doing implementing, so I'm going to let them handle some of the questions. The question was, for the folks who hadn't heard, are we using DCB in our implementation of this cloud?
At this stage, we do not leverage DCB yet, but that is the thing that we will planning to look at ahead and see how we can leverage all the hardware features that enables by Windows Server 2012. DCB is one thing, and the next step we are looking at right now is how we can leverage network virtualization as software defined. So how can we have a more complex network environment, right? So we are looking for the next Serverquarium, how we can leverage a lot of things in Windows Server 2012. Okay. Yes. So the question was what is the comparison between Matrix and System Centers? Is that did I get it right? Right. So in the Microsoft private cloud, it is about Windows Server 2012, Hyper-V, and System Centers, right? The System Center family that allow you to do virtual machine management, operation management, right? In the HP Cloud System Matrix, this is also the product that we have to build the private cloud. But the Cloud System Matrix also enables you to manage each generation's environment, right? So you can have all the hypervisor, all the operating systems also.
Yeah, okay. One point I'll make from an HP standpoint, We've actually developed some use cases where you can use a matrix operating environment to do the initial deployment configuration and then System Center basic ongoing maintenance and management. Clearly there are some, I'll say, redundant or overlap in some of the functionality between the two stacks. Exactly right, complementary. So what we're trying to do is actually drive further integration points up stack, if you will, like we've done at the insight control, the basic infrastructure management layer.
Yeah, I would definitely consider them complementary in how they do that. Kind of, by the way, think real quickly in terms of how we're using System Center. There was a great slide that had all the integration points. We're using System Center throughout, obviously, and HP is plugging in whether it's Ops Manager or using Orchestrator for automation and PowerShell. But if you kind of look holistically how we've kind of done things and how we're using System Center during runtime and during lab usage. So VMM was used to do all the physical deployments, all the host deployments, all the blade deployments. VMM was also, as mentioned in the talk, SMIS was used to do all the storage management. So that's really nice. But also there's the fact that, well, what happens when you're going through the lab and what happens if there's an issue? You know, you need to do some sort of, you want to raise an issue, you want to, raise a trouble ticket. Well, we're using Service Manager. So if someone needs to, hey, there's a problem with Lab 65, let's go figure it out. I'm not even sure you guys have had any trouble tickets raised, though, because it's worked so flawlessly. So a couple. Okay. And in fact, another good point of the integration has been one of the things that they mentioned to me a couple days ago was one of the disks went bad. Just, disks, it just happens. And in fact, Ops Manager fired up a little red alert sign. They didn't even realize it for a few hours because it's just been running like a charm. And they went and found Operations Manager said, and we looked in the rack and yeah, there's a little orange light, so we pull out the disk. So, I mean, it's just seamless. It's seamless and it's completely integrated across the entire stack. The other thing I want to remind everyone is everything is redundant. So the blades themselves, everything is clustered using Server 2012, clustered and cluster shared volumes. The storage is all redundant. It's MPIO, so multipath IO. So if any path fails, just continues right along. So virtual machines, the networking is also redundant. So everything is using 2012 LBFO and Team NIX. So if anything goes down there, it's all being done there as well. So from a power perspective, everything's on UPSs. From a storage perspective, everything's redundant as well. So I mean, throughout the entire configuration, the whole thing's redundant. Even though you could say in many cases it's probably not needed, but we wanted to deliver a complete cloud solution.
And I just want to share with you some of the work we did behind the scenes, right? As Jeff mentioned, we use SCVMM to deploy the Blaze servers, right? So really, we just configure the Blaze system, just have an ILO IP address. We go to SCVMM, we say, give me the list of ILO IP address. Here's a VHD. Boom. That's how we deploy Hyper-V server on physical server. And we did that 32 blades in 1 hour, right? And it's not just deploying the bits, right? Once we deploy the bits, we have some script to go and create NIC teaming, create Hyper-V switch, and add it into System Center. So after 1 hour, we already have the physical environment in place, right? So that is from the compute nodes. Now, how we do the storage. In the past, what we have to do in the storage, we have to go in using the management console of the storage and start, create runs, create big volumes, and then go back to Windows, have a system administrator, open up disk manager, create volume, format, etc. This time, we just set up the 3-part, and we just create the template for this type of disk group, right? This is RAID 1 volume, this is RAID 5, this is SSD. And then we go SCVMM, we just use SMIS provider, and we use SCVMM to create LUN, and automatically SCVMM will format it to Windows, present to the host, and done, right? And we do that only once. Just a wizard, click, 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 click. At the end, what we do? Oh, there's a button, show script. We take the PowerShell script, and that's how we automate. We have this PowerShell script, we go to Orchestrator, we plug in this script, and this is how we have a workflow. So simple. And I can tell you, this is by far the easiest setup I have since years. That's why I'm smiling today, right?
By the way, you guys are here. Who's running the lab, by the way? It runs itself. Okay. All right. Awesome. One other thing. Oh, sorry. Go right ahead.
We start every year. He asks if we build out from scratch every year. We do. We don't get to keep all of the gear. For some reason, HP wants it back. I don't know. I think they should just leave it with us, but... No, we... when did we start this year?
We started
Beginning of March?
first week of March.
Yeah.
First week of March.
Take that in. Think about that for just a second. They started this from scratch with nothing in March. They delivered a complete end-to-end solution, delivering thousands of VMs every couple minutes. Over the course of the week, we're going to deliver over 50,000 VMs, all in a very, very compressed amount of time. That's one of the reasons I, again, cannot say enough about these guys and the fact that we refine the process every year. And again, this is an orderable SKU. This is an orderable product. This is not pie in the sky, hey, I've got to go, try and, this is available. It's real.
You're making the lab available to attendees for another 6 months. And have you considered making that a subscriptionable thing that would continue the corporation may choose to keep the subscription open for dealing with something like that?
We do have some online training. It's a little bit outside my purview, so I can't tell you the exact details, but we actually do have online and training so people can do this year-round. We like to keep this one up and running because it's, for us, again, we learn a lot. I mean, for us, this is a, we love building this and deploying this, but trust me, these guys are sitting behind the consoles looking at all the statistics, really trying to understand, okay, how do we tune this next year? And I'll be honest with you, this is going to be a challenge. And I say this every year, but this gets so much better every year. It's like, how do we build on and how do we, make this even better next year? So, yeah, we do have some training online as well. So it is available year-round.
Is the training as integrated as the online lab that spins up virtual machines?
Yes. Yes. Yeah. It's also doing something similar where it's creating the VMs online and firing up the labs individually as well.
You need more blade chassis and more nodes. That's it.
The question is, so what if you want to extend this further? Actually, that's one of the nice things, and I'll pass it to you in 1 second, is the fact that this is actually built with a lot of headroom in mind. So right now we're using 32 blades, but each blade has 256 gigs of memory. Okay, that's not even maxed out. We could take it up to 512 per each blade, so that could go up higher. In terms of the scale-out storage, they're using a 4-node scale-out system. Okay, it actually can go all the way up to 8. Okay, and what's beautiful is if you go by the Serverquarium, you'll see we have a bunch of screens that are out there displaying a whole bunch of statistics and all the live storage and all utilization usage. One of the charts up there is actually showing how the 3-par storage heads actually disperse their load across the 4 heads. Okay, and by the way, the reason why they're 4 heads is it's resilient as well. So if any one of those goes down, or any 2 of those go down, or any 3 of those go down, guess what? It just continues to run right along. And the reason why you do 4 is because you get better disbursement across your compute nodes as well as your storage nodes, and you get better scale. So if you wanted to add a 5th, a 6th, or 7th, you've got headroom to grow there. If you want to add more storage, you add some more storage trays, and there you go. What did I miss?
Actually, I think that covered it, but I would say a couple of things. That with 2012 now, one of the limitations could have been trying to scale up virtual machines. Now with Microsoft 2012, you have a large number of virtual machines, large memory. So you could scale up as much as you want in an environment and then scale out. And if you have any load, most loads will scale out, and most loads now will scale up with Microsoft. So this is pretty unlimited because each Virtual Connect environment is a separate module. You can have multiple Virtual Connect environments, multiple storage, and multiple blades. And as long as you design the I/O subsystem properly and combine the scale-up part with virtual machines and scale out, this should really scale well.
So what is the ratio between how many blades server and one per virtual connect ratio
The ratio of virtual.
How many, like what per virtual connect, how many receiver it can, not blades, like how you connect it through the virtual connectors, the internal 10G channel, you know. You follow my question?
I think the question is how many blades per virtual connect interface?
Okay, so the VertiConnect is a converged device for network and fiber channels, right? So in the back, if you look at the back plane of the blade systems, you have slot that you can just plug the flex fabric, the VertiConnect inside. When we plug the VertiConnect here inside the enclosure, it will expose. When we configure the VertiConnect, it will expose all the fiber channel and network for 16 blade, for the whole 16 blade, for the whole enclosure. Okay? Just one chassis. And of course, I can add additional VertiConnect flex fabric, and so I can have more virtual networks, right? Yeah, right. Okay? And you saw the diagram of the VertiConnect virtual networks. We use the Hyper-V fast track compliant network architecture where we have a CSV, the line migration, the production, etc., right? So that is the current best practice. And now we are working to think about the next versions of the Serverquarium, how we can leverage the converged Hyper-V network, Hyper-V switches, how we can reduce the number of networks inside the VertiConnect so it can leverage the capabilities of Windows Server 2012 switch, right? So we can have a converged networks over there. That's all the things we think. We already think about what we do for the next step.
And if I could just add to that, we have an engineering team, and they've just recently published reference architecture for the storage. Actually, it's a 3-power storage, and it tells you exactly how to set it up in this environment using SMIS. So we're doing, as part of the joint, what we're doing a lot of reference architecture work. So we have virtual system is a solution that you can buy built, but not everyone wants to buy that. So our engineering team is working closely with Microsoft, and we have cookbooks for Virtual Connect that tells you how to build Hyper-V network environments, like Doug said, that tells you how to do it with Virtual Connect, so that if you want to do it yourself, you can do it yourself. So we're happy whichever way you want to buy and build our joint products together.
Yes.
I've got a question. How does the Microsoft Private Cloud Fast Track program match to the virtual systems of HP?
How does the Microsoft, I'm sorry.
Private Cloud Fast Track match to the VS systems?
Oh, that is a very good question. So the Serverquarium, the hardware. Oh, the question was how does the virtual systems, HP virtual system, match with the Microsoft Private Cloud Fast Track architecture? It's an excellent question because the hardware you see here, right? The hardware you see here is based on the virtual system VS3, right? Virtual system VS3. We are now validating that with the Microsoft Fast Track team to make sure that the Serverquarium is fast track. So by the end of this MMS, we will have this solution fast track compliant.
This is a fast track configuration.
Right.
Yeah. Just real simple. It is. Very much so.
What discrete RAID type are you using? Is it doing disk I/O balancing, deep hotspots in your RAID system?
You do the red. Can you repeat the question?
So he's asked what kind of RAID groups we're using. So we're using actually 4 different, right? RAID 1, 5, and 6 or 3 different across different disk groups, and using adaptive optimization to just tier across it. So it's all automatically balanced. We haven't really done a whole lot of, oh, well, this node needs to go on only this kind of RAID, because we just let it spread. As it gets used more, it gets moved to faster storage.
We should probably Just really quickly, I'm not sure we mentioned this, but when it comes to the storage, so we're taking full advantage of the 3-par tiering, just absolutely. So there's actually 4 or 5 levels of tiering. So first of all, in the blade itself, we've got the Fusion I/O card. Okay, so you're getting 1 layer. Then at the when you go to the 3-par array itself, the storage heads, each one of them has its own memory cache as well. Then we're going to actually go hit physical disks. So we've got SSD. We've got 15K fiber channel, and we got 7200 SAS. So what happens is this means we get the best of all worlds. We get storage, we get capacity, and we get crazy IOPS because we're using SSD memory and Fusion I/O. And so we get the raw capacity, and what happens is with the 3-par stuff, it knows, guess what? If everybody went and hit the same lab at the same time, it knows where all the hot blocks are. And guess what? If there's a lab or 10 labs that aren't being used that nobody cares about, guess what? It's being migrated to all the cold blocks. So what's great about this is you define the policy. Okay, you don't want to be going in there and trying to figure this out yourself. You define the policy and you let the 3-par do it, and that's exactly what they've done. I'm not sure you've done anything special out of the box other than what the 3-par does.
No, absolutely not. We just define template, red 1, red 5, and then just let it go. And one point, talking about multi-tier of cache, of storage, right? I have one story to share with you. At some point on Monday at 2 p.m., where we have 2,000 VM concurrently running because of the instructor-led hands-on lab in the back room, they start to create the labs. We have 2,200 VM across, right? The cache, when we look at the 3-par cache, we have a spike of 400,000 kilobytes per controller. Let's say 400 megabytes per controller. We have 8 controllers. So at this spike, we deliver 400 megabytes multiplied by 8. That means 3.2 gigabytes in one spike. And that's how we can build 1,000 VM in 5 minutes. Right? So that is very important because, as Jeff mentions, when you build a private cloud, it's not just about one component. It's about balancing the workloads, balancing the throughput, the workloads from compute, from network, and from storage. And this is how you can make the Serverquarium screaming, right? Yes.
Oh, yeah, I'm sorry, I missed the question. What was the testing we did on the redundancy? I don't know, did you guys start ripping down any cables yet?
Not on site.
Fast track compliance testing.
Oh, yeah.
Yeah.
Hey.
It's part of the fast track validation is we absolutely do all that. I'm fairly certain they probably did this back in Redmond in the test lab, but once we get it here, we're actually so focused on getting it delivered, I'm not sure anyone's actually done that on premise.
Can I start first?
Yeah, because you're the one who was doing it 2 years ago.
Yes. It was my fault. So we build all the rack with all redundancies, right, from the power up to the network, etc. So at the Serverquarium, we have UPS battery. So at some point in time during the lab test, I just unplug the cable to see how long we can survive with the power failures. So that's easy. At the VirtualConnect, I have VirtualConnect. I put 2 VirtualConnect devices for redundancy. Okay, and I think in last year or 2 years ago, we have exactly same setup in terms of hardware. I just go in and take one VirtualConnect out, fell over there, both fiber channel and Ethernet. But the story that he told me that at some point I completely forget where is the VirtualConnect, so I just take the whole enclosure and I plug it out. And of course, I lose things, right? Because I have only one enclosure.
By the way, one of the program managers who was leading running the instructor-led labs stopped me yesterday in the hall, and he was just like, by the way, I forgot to tell you guys this. He just wanted to say thank you to the guys delivering the test labs. And I said, why? What's so cool? And he's like, I normally, we run these labs, he builds these labs back on hardware in our test labs in campus, and we don't have this type of kit just lying around in our test labs. And he basically said, look, I fire up a whole bunch of VMs, I walk through my instructor-led labs, and I even have, as I walk through the lab, I expect, it's going to take a few seconds for this to happen, it's going to take a few seconds for this to happen. He's like, it's all instant. He's like, my labs are actually a few minutes shorter than I thought they were because everything is so fast and I've never seen a system this fast. And it's running like 12 VMs. Okay, this is like one of those, 25, 30 gigs of memory type things, 8, 10, 12 VMs on the back end. He's like, I've just never seen a system this fast. And he's like, there's no wait at all. And we're like going right through the lab, and it just finds it's actually flows a lot better and just makes his job easier. So I think we're just about out of time here, so we'll be up here for a few more minutes. If you have any further questions, please let us know. But thank you very, very much. We appreciate your time. And if you haven't gone by the Serverquarium, you'll probably see one of us down there. Please stop us and ask us questions. We're happy to walk through and actually point out the different parts of the solution. And again, enjoy the rest of this week at MMS. Thank you.